Alright, now let's test the basic part of my design. Let's press S, the light comes on. And L, that's locked. S again, 3, 1, 4. Now it's unlocked. So the lock and unlock function works. Go to the circuit. I'm going to do a demonstration again. Slow it down, okay. So power up. I have 4 states here. The last one's here. I add it up later. Press S. Try to lock it first. Let's watch the light over here. Okay, now that tells me that it's locked. It gives me a signal and the light comes off. Okay. 3, 1, 4. Okay. Now let's try to unlock it. Now the light comes off and the lock activated with 1 and CMD is 0, which was for 1 cycle. So this unlocks the lock. Okay, so I have 4 states. These are the state functions here, down this direction, and here. These are the output functions. I use a module that's called data path to provide input for my state function and output functions. Here's the input. They're the output of this module called data path. Now in data path, I used other modules such as X, key detect, K-match to generate the output I want to have to feed into the control path. Now, key detect tells me if a key has been pressed or not, has 2 states. K-match, I use 3 registers to compare each number to 314. If they match, the K-match is 1. Okay. Of course, I have a bunch of conditions to control what's being pushed into the register and what's not. So that, SLU don't go in there because they're not numbers, they're not valid. X is just tells me that when 1 key is being pressed, if any of the other 13 key is also being pressed. So this is used to tell me gives me the invalid signal here. Here, this is invalid. It counts the number of bits. That's 1. So if it's more than 1, it's not good. It's invalid. This is no key signal. Okay, they all feed into K-match. Okay, so that's the basic part. Now let's test the extra credit part. 4.1. It's locked. It's unlocked. Let's try to program into a new user code. I'll set it to be 1, 2, 3, just because it's easy to memorize. Okay. Should be fine. Should be set. Okay, let's try it. 1, 2, 3. Okay, good. That's unlocked. So for this part, it's a lot similar. It's very similar. I have 6 states: state function, output function. I have this module. I changed the name. Now it's called preprocess. They provide input to my state function and output functions. The 2 additional functions. One is called isValid. This tells me if the 12-digit sequence the user entered after pressing SP is correct or not. If they are correct, they are what they're supposed to be, and then this value is going to be true. And this is the new user code that the user put in. So these 4 are going to be the input of my store user code function here. Okay, this if it's valid, the valid output goes here. So the three user code valid, and if it's valid, these three user code would be pushed into the three registers here, so that the new user code is stored in these three registers. One thing that I used RST, I used MUX and used RST as the control bit, so that if it's 314 is going to be fed into these three registers. That's when it's powered up, so that it's 314 default user code. So that if it's RST0, after power up, so that these three registers would take in value from here, the three user code. So those are two different functions than in the first part.